One of the simplest mathematical models to understand for mathematical distributions is that for the uniform distributions. Here's the form of a uniform distribution. This one happens to be a specific uniform distribution that ranges from 0 to 20, but the range could be any finite range that our data follow. And the unique characteristic about this distribution is that there's the same probability of obtaining a data point anywhere within the range of the data. So the values from 0 to 5 are just as likely as values from 5 to 10, 10 to 15, and 15 to 20. So we say that the data are uniformly distributed because there is no place where we have a peak in the data within that range of data. Some of the properties of the uniform distribution. First of all, it's definitely platykurtic. We don't have a peak in the middle of the data. The data is flat along the entire range of the data. We have light tails. In fact, we have no tails. You have a range from some point, say A, to another point, say B. In the example we looked at, it was from 0 to 20. And then after that, there are no extremes. There's no individuals or units that have a few at the very bottom and a few at the very top. The range or the data set is uniform across the entire range. So we say that it's a light-tailed distribution. The parameters for the uniform distribution are simply the minimum and maximum values, A and B. All the values within the range are equally likely. The mean of the uniform distribution is simply A plus B divided by 2. That gives us the center of the distribution. So if the distribution ranges from 0 to 20, then it's simply 0 plus 20 divided by 2, or 10, right there in the middle of the distribution. If the distribution ranges from 10 to 30, then it's 10 plus 30 divided by 2, and that gives us 20, again, right in the middle of the distribution. The standard deviation of the distribution would be the square root of b minus a squared, that's the range, squared, divided by 12. The square root of the range squared divided by 12. The only reason that this fact is important at all to you is if we are comparing distributions and we want to compare, for instance, to the standard normal, then we'll be able to calculate the standard deviation of the uniform distribution. But I would not consider this a formula worth going around memorizing. Okay, so these are the basic properties of the uniform distribution. And it's a distribution that should be fairly recognizable, and also one that you could, from a theoretical standpoint, you could anticipate. When we generate random numbers, we often do so using a uniform distribution. That is, we say we want to generate numbers that are equally likely in a range from, say, 0 to 1, or 0 to 10, or 0 to 100. And so if you look at most of the statistical software packages, the built-in random number generators, especially if they have just one random number generator, it's going to generate numbers that you could then look at the distribution of those numbers, and if you plotted the histogram, you would find a uniform distribution.